Hey guys, this is your Miss Amara. So I'm back with my second video. So it's still the same section 3-5 and it's on page number 321, and today's lesson is on solving log equations. Okay, how do we do this? Again, key is the same. So pretty much you should be able to switch back and forth. If you start off with log function and you know how to switch it to exponential, that's what we do for solving. So you need to switch log into exponential. So here comes my first example. So I have log of x squared and it's equal to 2. First step, try simplifying, try applying properties of log if you could. So like this one, I know there's a 2 on the top, and based off one of the properties, you could actually put it on the front. So this becomes 2 log x and it's equal to 2. So isolate this expression. So I would divide by 2 to isolate the log expression. This becomes log of x and it's equal to 1. Time to switch. I hope you remember, if there's no base number, it's base 10. So this becomes 10 and swap. 10 to the first power makes it equal to, oh, my bad, makes it equal to x. Here you go. So my answer would be x is equal to 10. All right, last thing you gotta do is you need to check your solution. Now the reason we check, because you know negative numbers are not acceptable for log function. So you just have to go back, take the solution, check it, plug it back into original, see if it works or not. Whatever makes it negative, that's going to be extraneous solution. So let's take this 10, plug it back into this original. Yeah, that would still keep it positive, so it means this is a real solution. All right, so this is my first example. Next one. So let's say I have 2 log x to the base of 3 plus 5. Again, I would I would isolate this log expression first. So take away 5 and divide by 2. This becomes 5 over 2. Time to switch. Bring down the base 3 and swap 3 to the 5 over 2, which is same as 2.5, and it's equal to x. So 3 to power of 2.5 is equal to 15.58, and that's my solution. Now time to check. Again, I'll take this answer, plug it back in here. So do you think if I plug this back in this, it would make my log expression negative? Nope, it would not. So it means that's a real solution. It's not extraneous. Here comes my next example. Next example is I have log of x minus 2 to base of 2 minus log of x to base of 2, and it's equal to 2. All right. This is slightly different than last example. Why? Because we have multiple log pieces in there. So how do we do it? So you need to condense the function first. I hope you guys remember how to do this. So condensing means based off these signs, you need to make it into single log expression. So this becomes log, I see minus means x minus 2 divided by x, and base stays the same. It's equal to 2. Now log is already by itself. Time to switch. I would bring down the base, which is 2, swap 2 squared, it's equal to x minus 2. Now this is just like normal equation. So 2 squared is 4. It's equal to x minus 2. Solve for x. I would add 2. So x is equal to 6. Here you go. Time to check. Let's take this number, plug it back in here. So 6 minus 2, that would still keep my log expression positive, so it's a good answer. Then 6, yep, so it means either ways it's going to be a real solution at the end. Almost there, one more. So let's look at the last example. So last example I have is, almost there. Okay, in order to understand the example, let me show you a property here. So pretend it's a log property. Pretend you have log on both sides. It's an equation. And log with the same base. So let's say this side has 8 on this side, and this side is x. Do you think you can find x is equal to? Yes, I know x would be definitely equal to 8. Why? Because it's an equation. Log shares the same base. So I know this expression has to be equal to this. So this is something we're going to use for our next example. So my next example is, I have log, just a second, my bad. Okay, I'm sorry, it's ln. It's ln 3x minus 2 plus ln x minus 1, and it's equal to 2 ln x. Okay, again, just like last example, I have multiple log pieces. You need to condense it first. So if I condense this side, it would become ln 3x minus 2 and x minus 1, and it's equal to ln of x squared. All right. Now this is just like the property I showed you. It's an equation. You have ln on both sides. It means this implies that this whole expression is equal to this expression. So here's the shortcut. You could just cross out the ln's. So pretty much I know 3x minus 2 times x minus 1 would be equal to x squared. Now just solve. So first I would distribute this. So let's distribute 3x to the second minus 3x minus 2x plus 2, and it's equal to x squared. This is definitely going to be a quadratic function, so let's get everything on the same side and combine like terms. So this becomes 2x to the second, 5x plus 2, and it's equal to 0. Almost there. So I hope you remember how to solve quadratic, so you need to x factor. So let's try x factoring this one. 2 times 2, 4, negative 5. So two numbers. Multiply to 4, add it to negative 5. I have negative 2, negative 4 and negative 1. And remember, if there's a number for a value, we divide. So let's divide by 2. So my first factor simplify to negative 2. So my first factor would be x minus 2. Second one would be 2x minus 1. Almost there. Now, let me just write it on this, or I could just erase this whole part. So now I can set both of these factors equal to 0. So x minus 2 is equal to 0. 2x minus 1, and it's equal to 0. So this would be my first answer. And here's the second one. Almost there. Time to check. If I take this 2 back into original, do you think it would make any of the log expression negative? Let's see. 3 times 2, 6 minus, nope. 3, nope. Okay, so this is my real solution. Let's plug in 1/2. 3 times 1/2 is 1.5 minus 2. This is where log becomes negative. So this cannot be your solution. So that would be your extraneous solution. And this is all for today. Thank you for watching. Thank you. All right, bye-bye.